All right, guys, I wanted to revisit problem 25 from homework 2. And the reason I want to do this is because we've had a lot of questions about problem 7 in homework 3. And in relation to this bulldozer being 15 years old and us looking at something like this, say where every 20 years we would need to buy a bulldozer, right? So in 5 years, we'd have to buy a new bulldozer, and then every 20 years thereafter. And there's been questions about just how you would set that up. And as you know, we're not going to give you the answers to this homework before you do it. But I can put it within the context of stuff that we've done before, because concepts are the same. So this one was, and let's ignore the 100 acres so that the 75 comes out. Let's just do it on a per acre basis. That'll make things work. We have a 50-year-old stand of Douglas-fir, just like maybe you had a 15-year-old bulldozer. That's expected to yield $14.50. So this is a revenue instead of a cost, but think of it the same way. At rotation age 60. So at 60, I'm going to get $1,450, and then every 60 years from there on, I'm going to get it. Just like in 5 years, I'm going to have to buy a new bulldozer, and then every 20 years thereafter. So if you think about it, you would need to know what it looks like. So in this case, there I am in this year, and here I have the age of the stand is 50. In 10 years, I'm going to have a 60-year-old stand, and I'm going to get $14.50. And then when I go on another 60 years, so at 70 years out, $120. I'm going to cut it again, $14.50. So this is a lot like you having to buy, these are positives, buy a new bulldozer, and that goes on and on and on and on. So at 180, or 130 years from now, I'm going to cut this stand again and get some more revenue off of it. So fundamental to this is when we go to our sheet, understanding what our sheet is really telling us. So we know it's not one time, it's a series, right? We're pretty good at finding what this is. It goes on forever. It is a perpetual periodic series. What's missing here is perhaps what that means or where those values are. So if I'm looking at this series, this perpetual periodic that I'm going to carry it across over here, right? And my VO equals A over 1 plus I to the n minus 1. What does that look like in a timeline? At year 0, there's year n out, 2n out, 3n out, and on and on and on. We're going to get these A's. So what it means is when we solve that present value, we take all of these A's in the future and they come back to the beginning of the first in the series. So it's fundamental to be thinking about it when we're drawing these timelines and we're standing here at a point in time, right? And everything out here is in the future and everything out there is in the past. We can take these values with these equations and they move all over the place. It's knowing where we stand that's important, right? In this one up above, we are standing here. That's where we want to know our value. But the series, right, doesn't start where we stand. The series is irregular, let's say, because it isn't 60 years out that we're going to get the first payment. It's 10. And so when we apply this thing, right, it's important to know where the BO is that we solve. And in this case, right, where we're standing there, because we have to do two things. We have to kind of crunch all these series into a single number, and then that single number is going to exist somewhere in time, and then we need to either move it to the right, slide it to the right using simple compounding, multiplying it by 1 plus I, or slide it to the left, simple discounting, right, divide by 1 plus I to the t. And we need to move those values around. So when we crunch, they're not always going to work out perfect where we're standing. And that's the case with this one. And that's the case with your bulldozer. So when I did this before, right? I applied my VO equals A plus I, and I put my VO, and my A was 1450, and my 1 plus 1.07 to the 60 minus 1, right? I could solve what that was, and that was $25.46. That's what that is. That's what it is here. It's not what it is where we're standing. So I can look at this now in one of two ways. I can say, here's where I want to do it, because I don't like going into the past, right? I'm going to build this wall here with all these bricks in it, and nothing gets by me. In that case, I'm going to keep that value, assume that it's here, but then I got to account for this one, right? And then I can add them together. Why can I add them together? Because they're in the same time period. I can only add things together that are in the same time period. If it ended up and it was solved somewhere else, I would have to move it to be able to combine it with that 1450, right? So if I apply all these and I assume that this 2546 is here, right, I would then say that my VO for the problem, kind of where I'm standing at year 0, is going to be this 1450 plus the 2546, which is all the future 1450s, right? But it's here, and I need to take it 1.07 to the 10 back, right? And that would give me my $750.05. Option 2, okay, if I know that this is where the series goes, and I look at where this series actually began, it actually began way the heck over here, right? That's this point in time. So instead of stopping it here and adding this A and bringing it back, I can assume that I solved the whole thing. My $25.46 is here, and I just need to take it forward 50 years to get to where I am. So that's if I don't care about this wall and I'm just going to do things the easy way. And there my VO for where I'm standing in the end is going to equal 25.46 times 1.07 to 50. You know what that's going to equal? $750.05. Why? Because I just need to correctly account for where these values are in time, right? I could break it off up here, add this one to it, and move it back too. I'd have to account for this one individually and this one individually. I can break it up however I want. I just need to get them all in there, and I need to know where in time things are occurring and where I'm standing. Think about that with your bulldozer, right? The first payment is going to be in 5 years. You're not standing in 0. You're not standing at N. You're somewhere in between, and you're going to have to crunch and slide, and you'll decide the same thing that I decided, right? Whether I want to stay to the right, never let myself go into negative time, or whether I want to move back and then have to drag that thing forward. So, Greg, yeah, we think you're full of crap. It's probably not right. Don't believe it. So let's go look now at how that would look in the spreadsheet. So now you're looking at my spreadsheet, and let's just do it on a per acre basis. So I've got my 1450. Sorry, my keyboard is right over my microphone, so it sounds like I'm either a woodpecker or hammering away. I do hammer away a little bit on the keyboard, but not that bad. -1, right? And so if I type that in there, boom, just like I had said, that's the value of that series. That is one of those series, right, crunched into it. So I can do equals, assuming I never want to go over, the 1450 that's already there in the 10th year, plus this 2546, right? And I'm up in my little key here, and I'm going to bracket these off because I need to move this to the left, if you can remember, right? Divided by 1.07, and we were 10 years out, so to the 10, and there we go. And I've got my 750.05. So that's the method where I had to use the value that I crunched, but bring in this other A that I had missed and take them both back in time 10 years. Option 2 was just to take this value right here and bring it forward in time, 1.07 to the 50, right? And boom, what do you know? I get the same answer. So, right, same answer if I do it either way. I just need to be consistent. I can think of many different ways to do it where I break it up, as I said, but that's what we need to know. So same answer, know where you are. Think about where you are in these different timelines, right? It's at the beginning of the first period. That's where that VO is. Perhaps what I'll do is go another video where I'll draw out what these look like for each individual equation that we have. In the past, I've allowed people to have that on their sheet, the one thing they could have written on their formula sheet as they go forward. I hope that helps. So picture this now not as rotations, but these are new payments for bulldozers, and you're sitting here at year 15. You got to buy your first one at 20 and 40 and so on. How do you handle it? It's the same thing. I just want you to be consistent, right? Thinking about time. Values are going to be dropping into your timeline, and you're going to move them to the right by compounding, to the left by discounting, or using our other equations to crunch them, either on the left end, the present value when you're crunching it, or over on the right side of the series if it's a terminating series. Hope that helps. If you guys have any other requests, this was a request, so let me know and I'll post those videos. Thanks, guys, and I'll see you in class.